Hello, and welcome to our third session of our six-part webinar series brought to you by Rockflow Dynamics. My name is Jessica Kalin from the Rockflow Dynamics Calgary office, and today's session will be hosted by my colleague in Houston, Edward Evans. Our topic today is dynamic build-up well test simulation using tNavigator's Model Designer. We would like to thank each and every one of you for joining us today. These are new worlds from us working from home, and we are honored you are able to give us 30 minutes of your time for this webinar. Our RFD team is working around the clock to maintain and increase support for our clients, and despite the global changes, we continue to be there for you 24/7. During today's webinar session, all of our attendees' microphones have automatically been muted. Should you have any questions, please navigate to the GoToWebinar control panel where you'll find the questions pane. At the end of the session, we'll be addressing as many questions as we can, the remainder of which will be answered and posted online for your reference in the coming days. Additionally, this webinar session is being recorded and will be uploaded to our RFD Europe YouTube page, as well as uploaded to your FTP folder on our support website. Should you be left with any further questions following this webinar, please don't hesitate to reach out to us to our experts. Each webinar in this Global tNavigator series is hosted by 6 of our 30 offices worldwide. The first 2 sessions were hosted last week in Aberdeen and Kuala Lumpur. The third and fourth that are occurring this week are being hosted in Houston and Calgary respectively, followed by our sessions next week in Moscow and Perth. Today, we're live from Houston, USA. Our topic today will be discussing dynamic build-up well test simulation in Model Designer. For upcoming webinar topics, please reference this list that can be found on the webinar registration page as well as through our LinkedIn channels. Each of our webinars touch upon a different aspect within the integrated reservoir modeling process that is available in tNavigator. If you're interested in learning more about the complete workflow or would like to start a free trial, please contact us at asktnav@rfdyn.com.
Well, good afternoon, everybody. My name is Edward Evans, and I will be presenting dynamic build-up well test simulation. In essence, what we'll go over is how to combine high-frequency and low-frequency production data to make more accurate simulations and history matching. So briefly today, our agenda is going to go through an introduction, well testing and simulation, software demos, and finally a summary and Q&A period. So the first thing to touch upon is that tNavigator is a fully integrated solution, this with a large scope of functionality, which allows for deep and rigorous simulation studies. This integration also is a path for collaboration. The entire asset team's expertise can be leveraged because everyone sits within the same software. You have PVT, SCAL, reservoir engineering, wellbore modeling, geology, and geophysics, all within the same environment. So let's touch a little bit on well testing, its challenges, the challenges, different problems, and what we get out of it. So well tests help reservoir engineers determine, first of all, reservoir pressure, permeability and skin damage, minimum reservoir volume, boundaries and heterogeneities that the well can see, and it also assesses hydraulic conductivity between multiple wells. So limitations we couldn't see in well test analysis, it's very wellbore centric, which means that it only looks at a single wellbore. It may ignore the geology around it to a large degree, because ultimately what you get from it is just a KH, which is an average perm, and a skin. So as such, it's limited to a single wellbore. It doesn't really help you analyze if the geo model has been correctly modeled, correct? So there's also limited data. It does not take into account dynamic changes such as PVT data and rel perm, which change due to saturation or pressure changes. Another big challenge is poor or no communication can mean that any conclusion that comes from a well test analysis may not make it back to the geology team. So perhaps the geology team's interpretations permeabilities are completely off from what they see in the well test, and that information may not make it back to actually update the model and see if there is a more accurate solution. Another challenge for well test simulation is fine grids are normally required to capture the flow effects close to the wellbore, and also reporting times. Because well tests are done in inconsistent time steps that go up in logarithmic form, very often you need to sit there and go say, okay, from one date to the next date is going to be a second, and then 4 seconds and 10 seconds. And so there's inconsistent time step. And most preprocessors only have a single consistent time step, be it day, month, year, but it's consistent, right? So solutions. Well, the solutions that tNav offers for this are actually tied to each other because of the structure of tNavigator. The first one is historical production. Can be loaded into tNav using a CSV or one table format. Now, this one table format is basically a CSV table with different columns. And as such, you can actually combine high frequency and low frequency data. That means like data coming in on monthly rates and then data coming in at different time intervals in one big file, and it can be all loaded at once. This means that once it's in tNavigator, it's already integrated with the geomodeling, the processing, the petrophysics, everything that goes into building that model. And the other big advantage is that once it's in tNavigator, you can actually leverage all your computing resources to create a fast, efficient simulation to solve these complex cases. So without further ado, we're going to go through a demo that shows the main parts of this workflow component to load the data, run a simulation, then run a history match.
Start with a quick model review. It is divided by 2 faults, one running north-south, this can be seen here, and one running east-west. These 2 faults divide our reservoir in 3 different segments. There's a total of 6 wells, and it's a simple black oil model, so there's nothing special to this. The contacts are above and below the reservoir for now. And so that covers the basic reservoir description that we will be going through and using today. Now, the big important part about being able to model a well test is getting the data in, particularly the observed historical data. So the way we load that in tNavigator is through 2 different methods. We go to wells data. And wells data, we have a well production table. These well production tables are the observed historical data that we can load. Now, the 2 different ways we can load this is that we can load all dates all at once, combining high frequency and low frequency data in one large file. And we can see this in this manner. We'll go to import history, one table. And from here we have add rows. We click on add rows. I have this production CSV, which already has all the combined data. And I expand it to make sure that all the columns are where they're supposed to be. In this case, the columns are, the first column is date, time, well, BHP, oil rate, and gas rate. The key part to loading data is always being sure that your dates are in the correct form. In this case, it's day, it's month, / day, / year. So we have to make sure that this format is correct. So it's month, /. And the slashes are important because some software will use a dot, others will use a dash, so it's a slash. Next is time, and it's the same situation. Make sure that your time format is hour, minute, second, like so, and it has colons, right? You have different options as well. So once all this is set up, particularly this part, you press OK, and now you have well history. What if I have this in 2 different files? Let's say I have my monthly production in one file, and then I have the really high frequency data in another because I've extracted it from a different source. I can do the same. I can right click, say create. I'm just gonna give the default name. So first, I will load my monthly one table. So I'm gonna delete this one. I'm gonna load the monthly production. The column format is still the same, and I press OK. So it's monthly, so it's only 13 months to the historical data. So as you can see there, it comes 78. Now let's say that I then have the high frequency data in the well test, and the well test only has the single well that was tested, in this case A52, right? So I can just add that, append it to the previous one. I say OK, and now as you can see, it loads both files. So I have B18 coming in low frequency, And if I come down here, here's a high frequency for A52, which is the actual well test data. As you can see here, 0 rate and everything. And a recorded bottom hole pressure for the well test. So the next step from here, once the data is in, is to create a strategy. So we're going to go ahead and create a strategy using with a well production table 1, so you guys can see how to use one table versus the other. So the first thing to do is come to strategies. There's no strategy right now, so I'm going to right click here and say add new strategy, and you can give it whatever name you want. In right click, and I have to go to open time step editor. The time step editor defines our dates. So the first thing I want to do is I want to click on click on the little table for all tables, but what you want to do is you actually want to click on well structure and choose the specific well structure you use. That sets up the first date when the perforations come online. The next thing that we do is go back to the little drop down, say well production tables, and we can choose either one. It would be the same dates regardless. So we're going to click well production table 1, correct? So then, as we can see, you have the start date, which is February 27th, and the end date, which is February 27th, a year later, correct? Then you can see the high frequency data right here. Very well. So that takes care of the dates. Right now, let's say I want to make a very simple strategy. We're going to follow a liquid rate control. So I come to the first date, the start date. I right click and say add new rule. And here I can search for the rule. I can say historical. And here is historical well controls by table. I press OK. Right? So this prompts me to say, OK, how do I want to control it? So the first thing you'd say, what wells you want to define? I want to define all my wells from the same table. So I click all wells. What table do I want to use? Well production table. I want to say well production table 1. There would be no major difference. In this case, we're just using 1 to show you that there's an option to choose which one. Wells type detect by rate. Once again, they're all producers in our case, so it doesn't matter. And now here, when I click on producers, water injectors, and gas injectors, this just tells me how I want to control it. In our case, we want the well status to be open. We want to control by liquid rate. So we click on the drop down, say liquid rate, and I uncheck bottom hole pressure, so there's no limitation, right? So that's it. I've created my schedule. Now that the schedule has been created, I'm going to go ahead and go to cases and create a case. In cases, I have dynamic well and well test. Now the schedule, it's blank as well. I come to the plus button, and there is the development strategy we just created. It goes from February 27th, 2020 to February 27th, 2020. And I press OK. And now I run. So I click on the green button to initialize. That's good to go. So I hit run. Very well. Now that the simulation is run, we can compare our results. So I can come down to graphs, turn on the settings tab, and I'm going to say, okay, my well of interest is A52 for now. And I want to compare bottom hole pressures. Here's bottom hole pressure historical. As you can see, for the well test period, the bottom hole pressures are off by about 50 to 60 psi. So from here, I can start matching it and see there's a big difference in bottom hole pressures throughout time. So now I know that something's wrong with my simulation, and I can start a history matching process, right? And here's where we can do two different things. If we're interested in the well test, we can say like, well, clearly it's wrong. What does the well test give us? Well, the well test will give us an average perm. It will give us a KH and an average perm for the reservoir. So I can actually check this average perm to see if it makes sense, right? From the geo model, I can come to geometry objects. I'll do A52, and I'll use and right click on this perm and say object settings or object statistics, and it'll give me the statistics for well A52. I can click on well filter A52. What is the average perm? The average perm for A52 is 17 millidarcies, right? So from the well test, we know that our average perm should be 57 millidarcy. So clearly we already know that our averages are wrong, which means that it makes sense, right? Our buildup pressure is not building up as fast as it should or where it should be. So we already can tell that there is a big difference in what the perm should be. So from there we can determine, okay, we can correct for a bad permeability. So the way we would do that is we can close this. Here in the 3D grid, we can actually create a second perm property that would be our variable for history matching. So I'm going to say create perm optimize, right? And I'll make this a simple equation. Facies, because I'm going to apply a multiplier by facies, equals 4. Then perm times 1 else if facies equals 3, then perm times 1 else if facies equals 2, then perm times 1 else perm times 1 and if, right? So now that I've done that, I can close and see there is my perm optimized. In this case, it is the same. But the idea is that I'm going to make this into a history matching workflow. So what I would do is go back to the calculator and I can click on add to workflow. Now, if I go to add to workflow, I go down to my workflow. Now, if I go to my workflow, I can make a hotkey Alt-W or just come to project, workflows, and here is where this is. Now, I can start making a history match project from here. I would say input variables. I have 4 different facies, so I'll set 4 different variables. Variable 1, why not? Variable 2, variable 3, variable 4. And I'm going to set min and max values 0.5 to 5 for now. And I can do a multiple select. Okay, so there are my variables. Now I want to replace this multiplier by a variable. Click, highlight the area I want to do it, and just replace by variable. And that's it. So that covers the uncertainty part. There's one step that you need. You need to tell it to export model. And there you go. And now you can actually launch an AHM project, right? So to launch the AHM project, you now define this new perm property. So I'm going to come to cases. I'm going to duplicate my previous case, right? I'm going to come to static and update it for the perm. This way I can keep the original perm and not change it, right? So now that I'm using the updated perm, I can now launch an AHM. So I can click on the magic wand, project 1, workflow 1, use current hydrodynamic model. I can immediately launch a sensitivity analysis if I want, so I'll go ahead and launch a tornado plot by default. And I'll press OK. It's going to prompt me to say that the project has to be open and saved. So I'll press yes. It's going to initialize the project and then automatically launch AHM. So once it's ready to initialize and to launch the AHM, the AHM window will automatically open. In this case, Tornado is a predefined package, so it already launches the cases. So I can come to project info. This will tell me what experiment it's running. Calculations will tell me how each calculation is going, and the results will populate here as each calculation gets finished. So once the calculations are done, for example, I ran a tornado plot and a couple other calculations, we can go to the results, and this will show you all the results that were run. In this case, we ran a bunch of cases and we cleaned it up so you can see. In this case, we have a pretty good match for BHP already. In this case, it's any one of these 3 would be a fairly good match. I can define the objective function. In the case of the history match we ran, we defined it as only 852 is the only well of interest. And we told it that we want to use bottom hole pressure, a deviation of 14.7 psi, and an absolute deviation. We also specified that this has to use only the time steps related to the well test. As you can see, it's from step 5, which is 12 a.m. on the 27th of July, all the way to the 26th of August. So once it's matched, I have a couple options. I can actually right-click on one of these cases and say, and if I want to update the variable to the workflow I want to set, I can say set variables from this variant to workflow. I'll click on that, right? And I press OK. And if I go back to the workflow, I click on variables. See, now this is the new base values. Those are the best cases from the AHM. Start with a quick model review. This is a
So that covers the software demo part, and we're going to go ahead and I'll go to the quick summary for what we just saw. So tNav can leverage the integration for the asset team skills, meaning that everyone can contribute to the analysis as much as possible. So it's not just siloed information. We can have more detailed simulations. So tNav's high performance computing capabilities means that you can have more cores and run faster simulations in a smaller period of time, which allows you to add all sorts of detail to the simulation. You can add additional time steps like you saw using the high frequency data. You can add more cells. In the case of, in this example, the geologic grid was very fine scale, so there was no need for an LGR. But likewise, if you have a very large model, the load of cells from the LGR could still be handled efficiently. Finally, there's an efficient loading of the frequency data. So like, as you saw, you can have high frequency and low frequency data within the same file to make it easily loadable.
Thank you everyone for your time and attention today. For your reference, this webinar was recorded and will be available on our RFD Europe YouTube channel, as well as on our support website within your FDP folders. Now we will go to questions. I'm going to hand it over to Nestor, who will start answering a couple of the questions that we've got within the questions pane. If you have any questions, please do not hesitate to type them into our questions pane now. We will get to them as soon as we can. And any questions that are left unanswered, as we mentioned before, will be posted online.
Hello everyone, this is Nestor from Calgary. So there's one question here that says, can production data be loaded without dates? For example, as time from start of test. Yeah, the answer for that is yes. You could have, you'll need to set the start date first and the time, and then the dates could be calculated based on elapsed time. Let's see here another question. So there's another question here that says, can KH and average perm be outputted to a table to compare with actual well test results? Yes, for sure. A statistics table can be created, and then the simulation results versus pressure transient analysis results could be compared in the table. So it will be very easy to compare simulation results with the PTA software results that you have. So I think those are the two questions we have time to answer today. I will pass it to Jessica for the final greetings. Thank you.
Thank you, Nestor. For all the other questions that we haven't answered yet, as we mentioned, they will be posted online, as well as in your support website under your FDP folders. Thank you all again for attending our webinar today, and we hope that you can join us on Thursday for our next presentation that will be coming live from Calgary at 2:30 on Mountain Standard Time. The topic on Thursday will be modeling of multiple horizontal wells with hydraulic fractures in 3 simple steps, hosted by Nestor Hernandez. Thank you all. I will leave that Windows pane open, so if you guys have more questions, please feel free to put them in there. It will be open for a couple of more minutes. Thank you again, and stay safe, everyone.